Awesome, thanks. Well, welcome everyone and Happy New Year to you all. It's good to see a big turnout for us. I think January is always quite a busy JS monthly. I get, maybe there's not too much else to do this evening. Here in the UK, there's a few football games on, but I'm glad that you've chosen this instead of that. We've got two awesome talks that I'm really excited about this evening, and I think both of them get the prize for longest and shortest title ever. So firstly, we have Dwane, who's beaming in from all the way over in the States, who's going to talk to us about using web components in Angular, React, Vue, or not, as I understand it, which is just an awesome title. And secondly, we have Sam Bellen, who's beaming in from Belgium, who's going to talk to us about encryption using JavaScript. And his talk is entitled "No Way, Jose." So yeah, thanks for joining. I have a few messages and a little bit of an intro for you, and then we'll start with Dwane once I've given you a bit of an overview of what I think some of the JavaScript trends are in 2021. So yeah, this is the agenda. We'll have a comfort break halfway through. There's an announcement about CityJS, which is a conference we run every year. We're actually going to run it twice this year. And then we'll finish with Sam's talk. So firstly, I have to thank Pusher again for being a great sponsor. So Alex, who is doing the live stream and set up the Zoom call, and also very kindly donated the prizes for our Christmas quiz. Respect for that. Thanks, Alex. It's come good. Every event we've done for a long time, so it's really appreciated. For those of you that don't know what Pusher is, it's online services that simplify integrating real-time functionality into web and mobile apps. It's a hosted service with APIs, tools, and open source libraries. It auto scales, and some of their clients are GitHub, MailChimp, and the FT. So yeah, if you don't know them, if you need this kind of service for your application, check them out. Okay, yeah, so this is something that I've done the last few years, given a bit of a preview and a few predictions about what I think is going to be big in 2021, mainly based on previous data from things like NPM trends, but also, more importantly, from the big surveys, the industry surveys that are done. I hope some of you participated in them, because they obviously give us all this fascinating data to help us make good decisions, right? And I have also written this up in quite a thorough article, which is on my Medium page. I'll share the link in the chat shortly. But I just thought I'd share with you a few highlights for me. So firstly, I thought what was really, really interesting was, this is from the State of JS, was the satisfaction chart for build tools. And you'll see here that the landscape has changed quite a lot just in the last 12 months, right? So ES-Build and Snowpack have gone right up to the shared #1 spot for satisfaction. And I think the explanation for ES-Build is really simple. I mean, the whole remit of it is to be super fast, so for companies or engineering teams that need the build step to be as quick as possible. Maybe they're releasing really often. Maybe they got lots of different branches that need to build. Whatever the challenge is, this clearly helps you get faster. And so where speed matters, that's a great tool, and it's nice to see something really focused. Snowpack, though, is a much different proposition, and I'm really pumped about this because, for years and years I've been waiting for modular JavaScript to evolve to the point where native modules are possible or are more widely supported by third parties, and Snowpack helps us do that. So yeah, you can basically skip, in theory, the bundle step and actually run those modules directly in your browser, provided you're using third-party libraries that support it. And I think the way this has gone from strength to strength is, is testament to why they're so high in this. There's another way of looking at this, though, of course, and that is actual interest. So what's, are people more interested in these tools than some of the other newcomers like Rome? The answer is yes. I mean, Snowpack's right at the top there. So, I suppose what I'm saying is I see the industry, I see our community taking native ES modules really seriously, which I think is cool. And then just finally, let's just check, let's have a reality check, right? What's actually being used right now, which is a little bit different. And that picture is maybe more what you expected, with Webpack still way up there. Gulp maybe receding slightly. And TypeScript, obviously, right? It compiles code into different module formats. So yeah, it's understandably in there. And TypeScript's a bit of a theme throughout all of the research I did in this area, or of the sort of JavaScript landscape. And then I thought it was worth plucking out the ascendancy of Playwright. I mean, a year ago, this just didn't even feature in any of these charts. This screen grab is taken from the Rising Stars survey that's done. And the data here shows that, 20,000, almost 20,000 stars in 12 months is astonishing. I can't think of a tool that's been that popular that quickly. So it's quite incredible. But I think the explanation is, number one, it has an easy migration path from Puppeteer, but it has way more features. And it's a Microsoft-backed tool, right? It's Microsoft's product. So, when a big vendor like that outputs something that's really usable and pretty, defect-free, people are going to adopt it. But this is still really impressive. I think it's worth noting also that TypeScript support comes built in. So yeah, one to look at or one to consider if you haven't already. And then just finally, JS flavors, right? So I mean, last year when I wrote my summary of 2019 and made predictions about what would happen in 2020, I actually thought that PureScript was going to take off more, because I kind of felt that there was a lot of demand for having strongly typed JavaScript, but also for enforcing or encouraging functional programming, which is what PureScript aims to do. And as you can see here, satisfaction is pretty high. But if we look at interest, it's actually gone down. So that's a little bit of a shame. And then if you look at usage, well, it's still just on 2%. So it's just not really taken off, which is a little bit of a shame. But I think, the main explanation for that is just that TypeScript's dominance is enormous. I mean, just look at the figures, right? 78% compared to Elm's 6%. The closest contender there is, 72% away from it. So TypeScript wins, whether you like it or not. It's basically taking over our world, and actually I think it's added a lot of value. And yeah, and it's another really, really shrewd maneuver by Microsoft. And I think Nadella, their CEO, has made a lot of very good moves for their company's perception in our world, right? I mean, VS Code, I can't live without it. I don't know about anyone else, but they've made a lot of really, really great stuff. So yeah, I think this year is definitely going to be dominated by those things. But as I say, I'm really excited about Snowpack and native ES modules. Okay, just to wrap up, I mean, I would say that it's worth briefly commenting on Dino, which again, almost came out of nowhere. There was a lot of talk about it before it was launched, and yeah, this was the most starred GitHub project with 30,000 plus stars just in 1 year. So yeah, a new runtime for JavaScript and TypeScript. So yeah, those are the headlines. As I say, I'll post a link to my article. Comments are encouraged, debates are encouraged. But yeah, I'm gonna hand over to Dwane. Whereabouts in the States are you, Dwane?
I'm in the lovely state of Florida. Orlando, Florida, to be specific.
Very nice. Yeah. Hopefully you're getting a little bit more sunshine than us over here in London. But yeah, that's awesome. Cool. Well,
It's not too bad.
What's that?
It's not too bad. Yeah, not
I get the feeling you're playing that down slightly.
You ever heard of Florida Man?
Yeah.
So yeah, so it's pretty much true. So yeah, so Florida is an interesting place to live.
I bet. Yeah. I mean, yeah, if you can take a little trip on the Everglades, right? If you can head down to Miami, you can swim in an ocean that's like 28 degrees. That sounds good to me.
Yeah. Always a vacation spot.
Cool.
Alrighty. So then, nice. More, let's see. Alrighty, great. So thanks again for having me. And before I start, I like to experiment with things and try things. So if you would like to check out my slides page, it's actually at myslides.page. And there, the slides will be in sync. So as I'm scrolling through them, they'll also update on your end. Higher quality because there's no video compression, and it's as big as your monitor. So if you want to check that out. Have some interactive examples I would like you to play with as well. And now this is super beta, so I'm going to be using speech recognition. And so it's actually, as I'm saying things, it will put it like in a little speech bubble above my little avatar on the website. So hopefully you get a chance to check that out. Let me start some things on my end. So if someone could put I had my slides.page in the chat, but before I got to press enter, everything kind of went away. And I'm scared to put anything back.
I'll put it in for you, Dwane.
Awesome. Thank you very much. All right, so let us get started. Okay, so we're starting there. Let me move this over. And now hopefully you can see my screen with my slides and with this little speech recognition button happening, hopefully. And again, disclaimer, it's super beta. All right, so now, this, cool. All right, so using web components in your favorite framework / library or not, it's your choice. It's cool either way. As I understand it, January 2021, because the web is always changing. Hi, I'm Dwane, a JavaScript developer advocate at Vonage. If you're not familiar with Vonage, we are a cloud communication platform. Our APIs allow you to make video and phone calls, send SMS, Facebook Messenger, WhatsApp, and Viber messages, and so much more. So like I said, my presentation is about using web components, why and how I use them, and I'm going to show a lot of examples. It's got to double check something. All right, so I was not recording. Great. Okay. Okay, so yeah. So now, as it goes without saying that, oh, my bad. So like I said, my presentation is about using web components, why and how I'm using them, and show a lot of examples. So I'm hoping by the end, you become a part of the fandom. And it goes without saying that as a JavaScript developer advocate, I'm a fan of the DOM. And I live in a van called DOM. And I pretty much called it DOM so I could make this following joke. So hopefully it's funny. Light DOM, shadow DOM, virtual DOM. Now, if you're not familiar with web components, Anna Sidri gave a really good talk on the basics at a previous JS Monthly meetup. And there's the link to the video there. I've also been writing a series of blog posts that compares various tools to help create web components and actually build and publish a web component and use them, which goes deeper into what I will be presenting today. So you can always find those at that site there. But for the TLDR, think of a web component as your own black box in your application. The user of your web component can pass in properties and set attributes. Then they can even call methods you want them to use, that you want to let them use. If your web component emits some custom events, the user can listen for those in their application. Now, I like to build projects, as you can see, like a lot of projects. And one thing I don't like is having to keep creating or recreating about pages for each project, especially if they are built using different technologies. Ain't nobody got time for that. So for my newer projects, I've been using a web component, Dwane-made. And what happens is I fetch data from an endpoint on each project and pass that into the web component that changes some of the sections pertaining to that project. Another reason why I like web components is that they're almost like the Swiss Army knife. You can have the same component for multiple uses. So think of the humble input element. I've always found it amazing that just by changing the type attribute, its functionalities can change so much. So for example, we have the button checkbox, and now the color has always been pretty amazing to me. Like just changing that to color and you have a color picker. That's amazing. And then of course, this one is super cool. Now imagine if you had to create a date picker every time. Like this is great to me. So it's the small things that really get me excited. And then of course, you can choose files. There's the radio, range, and then of course the OG text. So now what we're going to do is we try to accomplish both features in the web component example used in the blog series that I mentioned earlier. And here it is. It's a keypad element. And so it was created using OpenWC and Material Web Components. Some of the properties and attributes on there are you can customize the placeholder text. You can set the buttons on the pad or the keys. And then you can set text for start and end action buttons. And then you can also show or hide the asterisk and hashtag keys or the pound sign keys, as well as the input box. Now there's a method on there. So there's the create action method, and it lets the web component know that an action has started. And as far as custom events, you can listen for the digit added, which is sent when a button is pressed. There's the digit sent, that's sent when the start action is pressed. And then finally, the action ended is sent when the end action button is pressed. Hopefully that all made sense. Okay, so now let's get into the first example. Let's start with vanilla JavaScript. Now, first, we need to load our web component. For this example, we will be using a CDN. So I'm using unpackage. There's so many, like we spoke about before, there's a lot of different new technologies out there. And so along with the web component, we will also load any polyfills that we need. So that lines 1 through 5 accomplish that. And cool. So go ahead and play around with the component. You can actually go ahead and press buttons in there, and you kind of see it pop up. And it doesn't do anything now. So, oh, it does something. I totally forgot about it. So, right now it's as if it's a basic dialer. So it's kind of like, do you want to call it? And then you say yes, and then it turned to cancel. Then you can end it. So that's the basics of the web component that we built for the blogs. All right. So now next we place our web component on the page, and it's actually, if anything that you get from this is that your custom element is just like a regular element. So it's like an H1 tag or a paragraph tag. And so you can place it on your page as if it's just like that. And so I have it here so you can see it. So I had to add spaces around the brackets because my slides were trying to actually load the web component. So you can see here, Dwane's -keypad, got a placeholder, and that's what's showing up there. And we're going to get into more examples of that. But continuing on, move that back. All right. Now, then we need to get a reference to the web component. And so we're doing that there. Like I said, it's just a regular element. So we're going to do a document.query selector and that. You can do, if you put an ID there, you can do, okay. I knew something like that was going to happen. This is what happens when you experiment with stuff. Okay, cool. All right, and so yeah, we're getting the query selector. Make sure I don't go back again. All right. Oh, almost did it again. Oh, okay. I do not like, okay. All right, so we're just going to keep on going. All right, cool. So now, all right, so we got the reference to the web component. And then here we are listening for the digit added custom event. Now this will call the keypad's create action method. And then if we wanted to programmatically change the action text, the button, we can do that like this. All right, so now let's take a look at some other options. So let's see. Now this is a code pen. And so we saw the default function there. Let me. All right, so now you refresh this. So now you see the action text, the button has changed to call. And now see right here, remove the actual display and the asterisk and the hashtag buttons. And now one that's kind of like pushing the limits, which is super cool, kind of shows the versatility of web components. At least hopefully. Now let's say if you wanted to create like a little gamepad, and so you'd be able to kind of move your thing around, that you can press this for the fire, and then you can have like how many times the person crashed and end the game. Cool. All righty. Now up next, we're going to go in alphabetical order here. So we're going to start off with Angular because I don't want to show any favoritism or anything. So now this image is from custom-elements-everywhere.com. And they do the work of making sure frameworks and custom elements can be BFFs. They run various tests and give a score based on how well a framework works with web components. So first up is Angular. And you can see that from the results and how it handles data going into and events coming out of a web component. They are BFFs. Now let's explore this more with an example. All right, so now in this example, the keypad component is used to enter a user's answer to a question. So it's kind of like a gamepad quiz thing. And then go ahead and give it a try. Do you know the answer? So in what year was the first release candidate published of Angular? Because it's Angular answers, so it's referring to Angular. Now let me, where's the mouse? Here we go. All right, so let's say if it's 1. Submit the answer. Oh, wrong answer. And since I actually wrote the question, I know it's 3. Mac. Okay. There, we got it right. Congrats. So now let's talk about how all this was kind of put together. So now first, we install the keypad web component. Now I tried to link to a CDN, but I couldn't get it to work. So if anyone is really familiar with Angular and has any suggestions, please let me know. Now in the app.module.ts file, we need to let Angular know that if it comes across any elements in the DOM that it doesn't recognize, not to worry, we got it. That is accomplished with custom element schema. I'm really hoping I don't go back again. So that's that's here. So we're importing that here at the top, and it's coming from Angular core. And then, so we import that from Angular core, and then it include it in the module schema, which you can see right here. Then we place our keypad component in the app.component.html file. Now notice the hashtag keypad. That will help us get a reference to the element. Those familiar with Angular will recognize the square brackets, which denote a one-way binding to a property or attribute of the component, and the parentheses for one-way binding to events coming from the web component. So you see we have the keys, placeholder, action text, and then just to show that you can statically, if you set it just to a string, you can do that there. So if it's not linked to like a variable that you want to change. And then the digits sent, we're listening for that custom event. Cool. Then we place our keypad component into app.component.html file. Oh, wait, I just said that. Okay. Okay, again, Apple. Okay, cool. So here we go. Yes, now in the app.component.ts file, we import element ref, view child, and our web component. And I don't want to scroll on here because it's going to mess up again. But as you can see here, we have the component, view child, element ref from Angular core, and then we're importing our web component right there. All right. Now, we use the view child decorator to find the keypad component using that hashtag keypad that I mentioned earlier. And then we create a keypad component reference of class element ref. And that's being done on line 31. Right there. Okay, go back. Okay, and then also you can see that we're setting the keys, the action text, and the placeholder. So we're setting those properties as well. Now, this here on line 42 will call the cancel action method of the keypad component. And so make sure to include, so we see this dot keypad, and then right here is important, native element, and then the method that you want to call. And that the native element comes from element ref. So that lets Angular know, okay, this element on the page has a method called cancel action. Okay. Now here we are programmatically setting the properties that were set initially from before, and that's pretty much it. Getting a web component working in an Angular project. And so see we have it here. So just this dot equals whatever you like it to be. Great. Up next in alphabetical order once again is React. And as you can see, the relationship with web components is a rocky one. The issues lie with how React handles data and events. React stringifies data going into the web component. So for strings, that's fine. But everything else like objects or arrays, or they're considered rich data, that can cause problems. Like the infamous object. I don't know how many people have actually dealt with React. You think you have passed in something, and on the other end, it comes out as object. That's why. So, and as for events, React has its own synthetic event system. So it can't listen to the native DOM and those events. So let's see what we need to do to get things working properly. Now, our keypad web component will be used in a React application as a dialer to make phone calls and then save the contact when completed. And so you can give it a shot. And no, you cannot actually make phone calls right now, but we go through how to actually make that happen in the blog posts using the Vonage Voice API. So now go ahead. So let me down here. Hopefully I don't go back again. There it is. So we can see here, here's the dialer in our React Rolodex. All righty. Call. So we assume that the call went through, then we can hang up and ask us for a name. And everything is in local storage. So, and there we go. And we can edit, delete it, and select it to bring it back into there. Cool. So hopefully you're playing around with that. All right. Now, so we're going to give examples using different versions of React. And here's an example for versions older than 16.3, because there may be some legacy code and you want to put in your web component so that when you upgrade, you don't have to rewrite all those things. And so now, like before, we load our web component from a CDN. You could also use npm install and import it, as we did with the Angular example. Now, we place the web component. So here is the web component in the render function. Now, notice that it has, towards the end here, a ref keypad. And it works like the hashtag keypad from the Angular example. And it lets React know to pay attention to this element. Now, on line 41 here, then in the component did mount section, here we're adding an event listener for the web component's digits sent custom event. So let me move this over here. So let me highlight that. So it moves over right there. So you can see it's a digit sent event that's coming from our web components. And then, cool. So now notice this.refs.keypad syntax right here. Now, if we had set the ref equal to, let's say, example, then it would be this.refs.example. And now you can use the same syntax to call methods on the elements. So we're doing that here. So this.refs.keypad create action. Now, here is how you would set a property programmatically. Here you can pass in the rich data that we mentioned earlier, but right now we're just passing in the string. Now, if you're using version 16.3 or later, you may want to use create ref. Now, the way it's done in this example, so the way it was done in the previous example, 16.3 or earlier than 16.3, the example there would be considered legacy and will probably be removed in later versions. So kind of make sure before you start using web component, which version you're using. So now let's look at the example. And just like before, bring in our web component, just like that. And then we add it to the render function again, but notice the ref has changed. So let me scroll over. As you can see here now, the ref is no longer a string. And so this is because of how React is creating the reference. And so now it's using create ref, as you can see right here on line 18. Now, the way to add event listeners and call methods is also a little different. And so as you can see before, now it says this.keypad.current. And that was different from before. All right. And then, so now this also carries over into setting properties. And it's also this dot keypad. Instead of like this dot keypad dot, this dot ref dot keypad, now it's this dot keypad dot current. So that's the difference there. All right. And so, as I mentioned before, the web is always changing and frameworks and libraries are no different. So kind of keep aware of where your versions are. But the one cool thing is that your web component isn't changing. It's just how it's being referenced. So now, as of React 16.8, webhooks were introduced. And they help with a lot of heavy lifting. So let's see how we can use them. Load the web component from CDN or npm install again. And like the previous examples, place the web component in the render function. But again, notice a slight difference in the ref property. Now, the only real difference in between React versions is the way reference to the web component is created and used. So if you look here on line 102, now see, it doesn't have the this dot anymore there. So it's just keypad. All right. So now, so in this case, we're going to be using hooks to create the reference. So here is the use ref hook, and that creates the reference. And then in use effect, in the use effect hook, you add the event listeners. And then here's how to call the create action custom event. So again, it's keep. So before it was this dot keypad dot current, but since we're using hooks, it's just keypad dot current create action. So a slight difference from the one before, but it's doing a lot more things under the hood. Okay, and so now if we want to set a property on the web component, this is how we do it. Pretty much the same thing, just without the this dot from version 16.3 up. Cool. So now, like I said before, I go into more depth into the blog post I wrote. And then we even build a working dialer that can make phone calls using the Vonage Voice API. Now, finally, let's talk about Vue. According to custom-elements-everywhere.com, using web components in a Vue application should be smooth sailing. So let's take a look at some examples. In our Vue application, the key component will be used to enter in a security code to open a vault, or should I say Vue alt? Anyone? Fine. All right, give it a try. So you see the security code there. Let me, where's my mouse? So let's go with 654. Let's see if that's right. Oh, nope, wrong code. And then it's 1, 2, 3, 4, the most secure passcode ever. No one ever thinks of that. Enter, success. And then we have a minion there, telling you succeeded. All right, so now, just like before, we start by loading the web component and putting the element in the application. So that's what line 1 through 6 is doing right now. Notice that the ref property is just like in React. So ref equals something. Vue has a similar way of binding to properties and events, just like Angular, except using a colon for a v or vbind and an @ symbol. Let me highlight it over here so you can see it. So here is, cool. All right. All right, here's the colon placeholder. And so that's going to bind to the placeholder variable. And then digits, so there's the @ symbol in front of digits dash sent, because that digits dash sent is the custom event that comes from the web component. And you listen for events in Vue with the @ sign or v dash on. Great. So now again, as with Angular, we need to tell Vue not to worry about any elements in our application that it doesn't know about. So in Vue 2, we use ignored elements. And it's an array that contains strings and or regular expressions that expose the tag names of the web components. So it is then passed into the Vue configuration so that it knows to ignore those elements. Now here is the initial value for the placeholder property. So we set it as enter security code. And then in the methods section of the Vue app, we call the keypad's cancel action method. And notice the $refs.name, and in this case is keypad, used in the ref tag in the element. And then programmatically set the placeholder is right below there on line 27. And now let's talk about Vue 3, the newer version. So everything starts out the same as in Vue 2, but the way to let Vue know about our web component has changed. It is no longer ignored elements, but is now is custom element. So instead of an array, is custom element expects a function. And so you see here in line 43, let me move over. So it expects a function that describes what to look for. Now also now in Vue 3, the check to see if the element is a web component is done during the template compilation. And that'll be important later. So now, other than that, everything else is the same as in Vue 2. Now, one of the newest additions to Vue is the composition API. It was created to help address some limitations developers were facing as applications grew over time and became more complex. Now, remember when I said that Vue 3 now checks to see if there are any web components during template compilation? So, well, there are two examples. So the two examples before, the Vue 2 and Vue 3, the way they were done, they were known as on-the-fly template compilation. And you can kind of tell when it's not. So when you ever have like a file that ends in .vue, there's a compilation step that needs to turn it into something the browser can understand. So now in this composition API example, Webpack is the compiler. So we need to look for the Webpack. We need to look for the web components in the Webpack configuration. So now there's different sorts of compilers that Vue uses that you can use for Vue. So just look for like the config file. And so you'll add this bit of code here. So that's what that's doing, is letting Webpack know anytime you see this, return the custom element so that Vue knows not to worry about it and that we know what we're doing with it. Now, the ref has grown in the composition API to include tracking other values, not just DOM elements. So it now needs to be imported and initialized inside setup. Right there we go. So yeah, so you can see right there, we're importing the ref from Vue, and then we're setting up the keypad with a null initially. So now notice that, oh, here we go. Cool. So now if you notice here, hopefully I don't mess this up. If you notice the dot value here, whenever we're setting either the placeholder or activating the cancel action method. So that's just a thing to kind of make sure, notice if it's not working, make sure you have the dot value. And then that's it. So we've just gone through using the same web component in different configurations with different functionality in different environments. So I hope that gets you interested enough to learn more about web components. If it did, I invite you to join the ride. And thanks. So if you'd like a deeper dive into what I presented, you can find the blog post here at dwane.in/Vonage. And lifelong.dev is my website. So if you'd like to get in contact, and here is a link to our developer documentation. And then also here is a coupon code for 10 euros to start you off to build something cool. Just press that and it'll show you the code. I don't want to show it on here. And then, yeah, thanks again. Woo, okay.
Awesome. Thanks, Alex. Brilliant. Thanks so much, Dwane. That was awesome. I mean, that was quite a whistle-stop tour of a lot of different approaches. So, yeah, thanks for squeezing that in. And do you know what? It's the kind of talk that I've personally been waiting for ages. I really think web components solve a lot of, long-standing problems for us developers. And I think a lot of people have struggled to understand how to actually integrate them into into their UI framework of choice. So that was super useful. There was a couple of questions in the chat. So yeah, if those of you that asked questions in the chat want to unmute and ask Dwane directly, please go for it. Chris, I think you had a question.
Yeah, hi. You mentioned at the start you're loading these in via a CDN. I was wondering if there was a performance impact for that, because I read the other day that loading Google fonts in via CDN is actually negative for performance.
It all depends on your use case. So that's what's cool about web components. You can do it both ways. So whatever your use case is, so that would depend on the CDN pretty much. So if you have like your own CDN is dedicated, that might be may fit your needs, because if you do that, then you don't actually have to keep, let's say you update that web component quite a bit. So anytime you'd have to, if you ever updated it, then you would have to update your packages and install it again if you did an npm install. Whereas if you do a CDN, you can do that. But if you know something that's going to be there for a while and you're going to keep that version, then you might as well like npm install.
Okay.
So web components are very versatile, which is a thing that I hope I got across.
Yes. Thank you.
Thank you.
Yeah, definitely. Yeah, and it was a really good question, because yeah, the beauty of them, obviously, or anything like this that can be easily distributed across different applications, comes with that. Yeah, do you do it at runtime or at build time? You know, yeah, when do you request the thing, and how do you keep it up to date? So yeah, good question, good answer. Okay, so who else asked a question? AK, I can see yours.
Yeah, hi there. Thanks a lot, Dwane, for your presentation.
Oh, thank
I
you
just want to check, have you, I know you showed building the web components from scratch. There are use cases, say, if you know, in a company, you say you're using Angular, you got reusable Angular components, you merge with another company that has React, they got reusable components, and you want to start, you don't want to build from scratch, but you want to convert current components into web components so you can use across the board. So Angular has like Angular elements.
Yep.
So I just want to know if you found any sort of limitations on this conversion pattern. So if you're converting stuff from Angular components to web components, using it in React, and converting a React component or a Vue component into web components and using it across frameworks.
Mm-hmm.
Are there sort of limitations you found that actually say X kind of component won't work?
Well, it's not necessarily,
only...
oh, sorry. I think there's a delay.
Go ahead. It's pretty much, I was just trying to add a bit more context. But
go ahead. Context is great. Go ahead.
Yeah, it was just pretty much around the converting native components you already have built into web components. Can you pretty much convert any kind of component into web component and use across frameworks? Or some frameworks, it's like actually you can't use this type of component. Only
like you
something
mentioned,
a bit basic.
So like you mentioned, Angular has Angular elements. And so that's a way of doing that. I think Vue has one as well. I'm not quite too sure about React, because React is more like a library. So it just handles kind of like the UI stuff. So I'm not sure if there's one there. But the thing is, now for your example, if you already have all these things in Angular and you want to convert it over to React or what have you, it may, depending on how much stuff there is, it may be easier just to go from using Angular elements. But then the thing is, you kind of like bring along the whole Angular framework with it.
Yeah.
Because it still because you still need Angular to kind of decipher what's happening. Whereas if you were just creating native web components, it's just using, you know, native APIs that come with the browser. So again, like with any, you know, developer question, it depends.
Yeah, because our scenario is not sort of our choice. It's just the business grows, you merge, and every company you merge with has their own JS framework. So you know, well, let's move to web components, and then you get this problem.
So now what you could probably do is carry over what you have now in using Angular elements, and then you create any new ones, just use
native web component.
Exactly. Okay. And then you can kind of go back and recreate them as you have time.
Sounds good. Thank you.
Oh, no, thank you. This is cool.
Cool. I think that might be all the questions. Well, it's all the questions that I can see in the chat. Does anyone else want to ask a question? We've got a couple more minutes.
Oh, okay. I thought it was over. Cool.
Well, let's try and squeeze one more in.
Okay. Yeah, sorry about anytime you try something new and experiment, there's always like a bug somewhere. So glad we got this worked out. Thank you for your patience.
No, it was awesome.
I was going to ask a question. How do you deal with like styling, and if you've got different frameworks like Sass, or you just kind of take the CSS, or you want to customize it in different applications? I suppose, is it just a similar sort of thing you can import it?
Yeah, so what you can do is, because there's actually, depending on what you're using to kind of create the web components, because I go through a bunch of tools and things that help make it easier. So you can actually, because there's like the layer, the shadow layer. So anything you do inside of the web component, so like stays within the web component. But there are ways to be able to apply styling to the web component. So you can have it where you don't want, because normally you don't want the styling to leak out of your web component. And then you're able to, because again, it's just like a regular DOM element. And so you can, apply styles to it if you want. And so there's different ways of making that happen.
Yeah, I mean, one of the beauties of web components is that they are completely encapsulated, right? They're protected from one another. But you could theme using Sass and have them inherit, right? But still have their own styles within them. I think it's kind of nice that you can just basically put a web component in a completely different context, and it should look identical, right? It should work exactly the same. Cool.
Yeah, so hopefully all of this lets people look more into, because the more people into web components, the more people that ask questions, and then it can kind of grow and get better and, easier and, more useful for everyone.
Yeah, I couldn't agree more. I think it's been a topic of many a meetup and many a discussion online, right, about whether they're really going to take off or not, and they kind of never really hit the big time. But I think talks like yours are really going to help with that. I think maybe it's a slow burner.
Well, it's always good to be then flame out quick, kind of, so it's kind of keep it consistent. And but yeah, so if anybody has any questions or anything, please feel free to reach out and stuff. So thanks once again.
Awesome. Thanks so much, Dwane. That was top. If anyone's got any questions while we just have a little break and they want to use the chat, are you able to stay on for a little bit, Dwane? Or
I mean, it's like 2:00 here. I'm fine. Yeah.
Awesome. Cool. Ask questions in the chat. Let's take a little comfort break. What time are we on? Pretty much past. So see you in 5 minutes, 25 to. We'll have some talk. Okay, round of applause, Dwane.
Have a great day or night, wherever you're at. think it would work fine because if you're calling APIs, I've never, that sounds like a good article, because it should work fine because they're pretty much just like DOM elements. It's just getting the browser to know that what to do with it. And so just like with the because I think you can do script tags, right, in the Jamstack, I'm sure. And so you can just do a CDN and it'll just automatically do it.
They'll definitely work. I suppose it's maybe a question about whether they can be whether we can static build a site that's entirely based on web components.
That's a good question.
Don't they need the runtime? Like, then they actually need to be executed in the browser so the browser knows how to render them.
I'm not sure.
Or have I misunderstood?
Yeah, because it does need to load it, but then if it's static, I'm not sure. I'd have to look into that. That's a good question. Thanks.
Yeah.
So what do you use for your Jamstack? So maybe I can actually look into it. Tristan, anything specific or?
Hi, Dwane.
Hey.
No, I just discovered that Jamstack thing. It's such a youth thing right now everywhere. I just attended a meetup in Netherlands.
Oh, nice.
So I just wanted to know if they worked, at the build time, because I guess that you need to create your components as npm packages.
Yeah. So if it's build time and it's in your, you should be able to.
I guess so, but this is very new for me. So I just wanted, because I still try to understand what we can do with web components, So
you can do pretty much anything that you want to do with web components, because it's like your own like little black box.
Yeah.
Whatever you want to have done there, you can make happen, pretty much. And so, yeah.
It's it's very cool, but wow, I'm learning too many things at the same time. So
yeah, that's the web.
Okay, thanks anyway. It's very nice talk.
Yeah, thank you. If you have any questions, just feel free to reach out.
Okay, I got your links and your web pages.
Nice. Thank you. Thanks for coming out.
Cool. Okay. Well, I'm going to assume, though I can't see everybody, but I'm going to assume that most people are back from their break, if they even took one. And I know there's been some pretty exciting conversation here, some pretty good topics covered. So if you didn't go anywhere, I totally understand, right? I mean, this is the place to be.
This is my favorite part of meetups, is just talking to people.
Yeah, this is what it's supposed to be all about, right? So I'm going to just for 2 minutes tell you a little bit about what's that? Yeah, thanks. So let's see if this video works. I just realized actually, Alex, that I didn't change any audio settings, so the music might be coming out of my laptop speaker rather than there's no there's no, let's say, core content in the audio, right? It's just the music. I mean, don't get me wrong. Yeah, I mean, the music's important to a degree, right? So if anyone's got a nice setup at home for Zoom and they've got like their big speakers, they're like stacks ready, it might not sound that great, but yeah, it's a 1 minute video, and then I'll just explain briefly a bit more about the conference. But as I said before, the JS Monthly organizers, in particular Aris, who deserves a shout out for for organizing City.js Conf, has organized 2 for this year. So there's going to be one in March, so not very far away from now, which, as you can probably imagine, is going to be online, because I don't think we're going to be quite out of lockdown by then. And then all being well, right? All being well, fingers crossed, the world is in a better place by September, where we can do it in a physical space, which would be Cinema. Okay, I'm going to play the video. Hopefully this will give you an interesting insight into what the virtual conference is going to be like.
Welcome to CityJS 2021.
So that's the video, and that is actual footage, you know, preview footage of what it's going to be like. So yeah, we've actually got an online app which is not a million miles away from Habu Hotel. Anyone remember that from yesteryear on the internet? That was awesome. It was like an isometric cartoon world, right, that you could make your way through, hang out with people in a hotel, chat to them, play pool with them, all that kind of stuff. It's basically like that for now, right, for the 21st century. It's a conference where, yeah, you can actually virtually hang out with other people. You can meet the speakers, you can ask them questions, you can go to different booths, meet sponsors, interact with other guests. So yeah, we have virtualized.
I'm getting Club Penguin vibes.
Yeah, I mean that kind of vibe, but maybe more educational.
What are you saying about Club Penguin?
I'm saying CityJS is better.
Fair
enough. So yeah, as I said before, March the 24th to 26th, tickets start at £30. There are various workshops which change the pricing structure. There's definitely some great topics. I will post the link to the site in the chat. And then, as I say, we have another one in September, where we hope to see you there in person. So yeah, thanks for listening, and yeah, we hope that you can join us. I'll stop sharing now because I want to hand over to Sam, who, as I said earlier, has joined us from Belgium. Whose talk is called No Way Jose and is about encryption in JavaScript. So yeah, let's dive in. Sam, are you there?
I am here, thank you. And I would like to thank everybody for sticking around. Let's just wait a few seconds until I can share my screen, and then we're off to some light subjects like cryptography, encryption, signatures, stuff like that.
Cool. Brilliant, thanks Sam.
Yep, there we go. All right. Let me quickly find the chat as well, just in case. And we should be good to go. So like I said, thank you everybody for sticking around. I know it's getting late, but I hope I can teach you a thing or two about encryption. Now, this talk is called No Way Jose, and you might be saying, what does that have to do with encryption? Well, Jose is a standard which basically stands for the JSON object signatures or signing and encryption. So it's a standard for using JSON with signatures and encrypted content. But before I can dive into the Jose standard as it is, we first have to see what signatures are and what encryption are. So I'd like to start with a a little introduction to the basics of cryptography before we move on to the actual Jose standard. So let me quickly introduce myself. My name is Bellen. I'm from Belgium, as introduced, and I'm a developer advocate engineer at Auth0. And if you don't know Auth0, we're an identity as a service provider, which basically means that we try to make it as easy as possible for anybody to implement a secure authentication flow so you can focus on building your actual applications instead of just worrying about your user's identity or worrying about signing up and logging in users. I'm also a Google developer expert, and you can find me all over the internet as @samego. I'm a web developer, so it only makes sense to me that I would be npm installable. So if you run npx @samego/about-me, download half of the internet and wait a few seconds, you'll find all the necessary links you need to contact me or to find my other presentations or this one on the internet. So if you would like to follow along with my slides, just like Dwane did, you can just go to jose.samego.tech. Mine do not automatically sync, so you have to skip forward with your arrow keys. But if you prefer the slides on your own screen, you can go to the website and follow along there. So I have to start with a disclaimer. And the thing is, I might simplify certain things in order to try to explain them in an easier way, because once you start with cryptography, it's very easy to go down the rabbit hole and get to very complicated matter very fast. So I'm going to try to stick to the surface, and maybe I simplify certain things just for the sake of explanation. Also, don't reinvent the wheel. Use existing libraries and services when doing something with cryptography, just because they have been proven, they have been researched by researchers or people who know actually what they're doing. So if you have to do something with encryption or signatures or hashing, use one of these existing libraries that have been proven to work. Okay, a little summary. We're going to be looking at hashing and keyed hashing, signing, encryption, and lastly, Jose, because the talk is called No Way Jose. So what is hashing? A hashing algorithm is a mathematical algorithm that maps data of an arbitrary size to a bit string of a fixed size, which basically means that no matter how big the input you give to this algorithm, the output will always be of the same size, and that size is depending on the algorithm. So if you input 1 word, 10 words, the whole book, the output will always be of the same fixed size. The initial data is often called the message, and the outcome of a hashing function is called a hash or a message digest. And hashing is a one-way function, which means that what you put in and what you get out cannot be reversed. You cannot reverse a hash once it has been hashed. You cannot get back to that original input. It's a one-way function. So if you look at a little diagram here on screen, if you have 3 inputs, dog, doggo, and a quick brown fox jumps over the lazy dog, and we all run them through the same hashing algorithm, we get 3 different outputs. But we can see that these outputs are all of the same length, 256 bits for this algorithm, but they're different. And we cannot take these outputs, these hashes, and go back to the original input because hashing functions and hashing algorithms are one-way functions. Input gets you an output, but the output cannot be reversed. So some of these hashing algorithms you might have heard of are MD5, SHA-123, NTLM, Landman. These are all hashing algorithms that are commonly seen when you're dealing with hashing. And a variant of hashing is keyed hashing. And this is basically everything that a hash is, but it also lets you validate the integrity and the authenticity of the content of a hash, which means that you can validate that the input has not been tampered with based on the key that's associated with this keyed hashing. And you can also validate the integrity or the authenticity that it's a real hash that you're expecting to have. So in order to compute a keyed hash, you need a secret key. So if you have the same schematic as before, input dog, doggo, the quick brown fox jumps over the lazy dog, and we run them through a keyed hashing algorithm. In this instance, it's hmax SHA-256. So still we get a 256-bit output. It's the same for all inputs. But together with the input, the dog, doggo, and so forth, we also input a secret. In this case, it will be super secret. Usually it's a randomish string that you have to keep secret to yourself. Otherwise, it would be useless. But based on this secret, the output would always be the same. If I would input a different secret for the input dog, my output would be different. For example, we have the same input, we have the input, the quick brown fox jumps over the lazy dog, and we have 2 different secrets, the real one, my super secret, and a wrong one, wrong secret. The output of that algorithm will be different for both secrets, even though that the input, the quick brown fox, is the same for both of them. This makes sure that if we know the secret, we can validate the authenticity of this hash, or at least of the input of this hash. Internally, it's a bit more complicated, and usually your secret key is converted to an inner key and an outer key, and then you first make a first hash with the inner key and take that first hash and use the outer key to the secondary hash, and then you get an output. You don't really need to know this. I just wanted to mention is that internally these algorithms are sometimes quite complicated, but the essence is quite simple. Input gets you a fixed output and cannot be reversed. Some of these algorithms are HMAX, SHA-256, 384, and 512. And of course, these numbers, they mean the bit length of the output. And if this just seems like some random letters, it basically stands for keyed hash message authentication code with a secure hash algorithm, and it's a 256-bit output, like I mentioned before. So it's not just random letters and random numbers. They actually do mean something most of the time.
So I was now recording. Great.
And keyed hashes are often used to store passwords. If you have to store passwords in a database, you might store them in a password.
So like I said, my presentation is about using web components, why and how I'm using them, and show a lot of examples. So I'm hoping by the end.
Oh. Okay, we good to go? I was talking about storing passwords in databases, and often you would store them as a keyed hash. But before you store a password, usually they are salted. And what this means is that you basically add a random or randomish value before the actual password or the actual data you want to salt, just so that the hash output would always be different. So this has a benefit that similar passwords do not have the same hash. If, for example, me and Richard and Alex all happen to have the same password and we would store them as a hash, a regular keyed hash in our database, these hashes would all be the same. And even though I do not necessarily know Alex and Richard's password, because our hashes are the same, we can assume that it's the same password as me. So if we add some random data to all of our passwords before we hash it, the outputs will always be a bit different. That's called a salt. And this also means that you cannot really use rainbow tables. And a rainbow table is just a very big database, a very big table with all possible strings and their hash outcomes. So if you add some randomized data, that would make those rainbow tables also useless. So the same example, we have our keyed hash algorithm, we have our secret, we have our input, the quick brown fox. But together with that input, we also add some random salt, in this case, a random string, and we get our output. So that's usually done when you have to store key passwords or some other sensitive data. Okay, we've seen keyed hashes and regular hashes. On to signing. And digital signatures offer all properties of keyed hashes. So everything a keyed hash has is also true for a digital signature. Plus they are cryptographic, non-repudiatable, or whatever you say. And they enjoy the principle of cryptographic non-repudiation. And it's a very fancy word. And if you look it up on Wikipedia, it means something like non-repudiation refers to a situation where a statement's author cannot successfully dispute its authorship or the validity of an associated contract. And that's still a lot of fancy words. So if we take a very simple example, we all know cash checks from back in the day when nobody had a credit card, but they had a checkbook in their pocket. And let's say in the 60s, you would buy a car, you would go to a car dealership, and you would pay your car with a check. Now, on that check, you would write your signature. And once the car dealership goes to the bank and says, hey, I got a check from Sam, can I please get some money in return of this check? And the bank would say, oh, but this Sam does not really have any money. Are you sure he signed it? The bank or the car dealership could be saying, I'm sure he signed it because his signature is on this check. No, a real signature is just a bit of ink on a piece of paper, so it's easy to forge. A digital signature is usually less easy to forge, but it still does the same thing. It can prove who created that signature. And that's what this non-repudiation means. It can prove who created the signature. So cryptographic non-repudiation enables other parties other than the signer to check the signature's validity. So I can share my signature with a lot of people and they all would be able to validate the signature validity based on a public key. So like I just said, digital signatures use public key cryptography or asymmetric cryptography, which means that you have a private key and a public key. And the signer is going to create the signature using the private key. And the private key is something you keep secret to yourself. It's private. It's called private for a reason. So you're going to create the signature with your private key. And then you're going to send that signature together with some data to whoever wants to receive it. and they can use your public key, which is something public that you can share with everybody in the world. And they can use that public key, which is linked to the private key, to validate the signature of that payload. And a signing algorithm is usually a collection of 3 different algorithms, something that generates a private and public key pair, something that signs or creates a signature, and something that's able to verify the signature, a verifying algorithm. So if we look again at a more schematic kind of way, our input is still the same. The quick brown fox jumps over the lazy dog. But if we run it to a signing algorithm and we use our private key, we get a signature. Now, if you want to verify that signature, we're going to take our signature, which is a D7, A8, and so forth, run it to that verifying algorithm together with the public key, which is linked to the private key we used before. And we would get the output, the quick brown fox jumps over the lazy dog. Now, if we see that this output is the same as the output we expect, the quick brown fox, we know that the content match. So the signature is valid. The content has not been tampered with. Signatures usually are hashed before they are signed, just so you have a fixed outcome, because we've seen that hashes always have a fixed length of an outcome. Before we run it to the signing algorithm, we usually run it to a hashing algorithm, but the concept stays the same. You use your private key to create a signature, and you use the public key to verify the signature. But instead of directly comparing the input and the output, you're going to compare hashes, which is always going to be the same for the same input. So some signing algorithms, the most commonly used ones are RSA, elliptic curve, or sometimes EC, and Edwards curve octet key pairs, or OKP. And RSA keys, they are often used in the RS and the PS algorithms. They're very fast to compute because they're relatively easy. They're relatively simple. That also means that they're quite CPU friendly, and they have a very good support because they're quite easy to implement and they've been around for quite a while. Now, they do require longer keys with a minimum of 2056 bits to have a certain amount of security, which means that you also get longer signatures, 2056 bits in this case. While elliptic curves, ES, they have shorter keys for the same amount of strength than RSA, which means they have shorter signatures, but they're a bit more complex, so computing them and verifying them is going to take a little bit longer. And Edwards curve octet keys, they're a bit of best of both worlds. They have the best signing performance. They're quite secure, but they are relatively new. So not all libraries out there might support them, even though that support for the Edwards curve octet keys are picking up, and most libraries are implementing them or have implemented them already. Okay, hashing, keyed hashing, signatures. On to the last part of cryptography, encryption. And when encrypting data, we cannot only ensure its integrity and authenticity, like we did with keyed hashes and like we did with a signature. The data of something that is encrypted will also stay secret for outsiders, which means that only the party that created the encrypted data and the party that is intended to receive this encrypted data will be able to actually read the data. So you need either a private key, a secret key, or a password to read the data. This depends on the algorithm that you're using. The encrypted message is often called a cipher. So if you hear a cipher, it usually refers to the output of an encryption algorithm, the encrypted message itself. And there's a few different kinds of algorithms. There's symmetric ones and there's asymmetrical ones. Both have their use case. Let's start with the simplest one, symmetrical ones. Some example use cases are file systems, Wi-Fi, database encryption. Basically, all systems that deal with a big volume of data are often encrypted with a symmetrical one, just because they're faster to compute, they're simpler. And what is a symmetric algorithm? Some of the algorithms are listed here. It basically uses the same key, the shared secret, to do both encryption and decryption. This makes the math underneath these algorithms a bit more simple. That's why we use them for big pieces of data. So if you know the shared secret, you can create both the encrypted message and decrypt that encrypted message. Now, with asymmetrical encryption, that's not going to be the case. The sender is going to ask the receiver's public key, because a public key, like we saw with signatures, is something you can share with the world, and it's going to use that public key to create the encrypted message. Now, this might get a little bit confusing, because when you create a signature, you create that signature with the private key and you validate that with your public key. With an encryption, it's the other way around. You're going to ask for somebody's public key and use that public key to encrypt the message, so that that receiving party, that person that just shared his public key, can use their matching private key to encrypt or to decrypt your encrypted message. So when the receiver receives a cipher, decrypted message, they're going to use the matching private key to decrypt that message. The same example, the quick brown fox, we're going to use the receiver's public key to encrypt. We get our encrypted message, and then the party that wants to decrypt it, that's the intended party, the intended receiver, can use their private key to decrypt the message and get back to the original input. Some forms of asymmetrical encryption are TLS, VPN, SSH. These are things, if you're dealing with web development, you might have seen floating around. And some of the algorithms are RSA, ECDH, things like that. So, like I said before, symmetrical algorithms are faster than asymmetrical ones just because they use the same secret to both do encryption and decryption, but both have their use cases. Asymmetrical ones are usually a bit more secure. So what often is being done is you use an asymmetrical algorithm to encrypt your secret that you're then going to use with your symmetric algorithm to actually encrypt and decrypt the data. So let's look at a detailed example. RSA. RSA, it's an abbreviation of the people that actually created this algorithm, but I'm terrible with names, so I don't remember those names, but it doesn't mean something clever. It's just the people who created this algorithm. And the first thing we need to do with RSA or with any of these encryption or signature asymmetrical algorithms is generate a public key and a private key pair. Now, cryptography is usually based on some algorithms using very large prime numbers, and RSA is no exception. And when I talk about very large numbers, do I mean a million? Do I mean a billion? Well, no, I mean something that might look like this, where this is a million, this is a billion, and you see how many other digits are on screen. You often deal with numbers which are 150, 300 and more digits long. I don't even know the names of these kind of numbers, but they're very big prime numbers, which means that computing these things is very intensive, very difficult. Also, this also means that brute forcing these algorithms is very time consuming and very difficult, and that makes them so secure. So we had to create our private key and our public key first. So in RSA, it's done like this. First, your RSA algorithm or your key generating algorithm is going to create two very large prime numbers, random. Our first one is P, our second one is Q. I've used very small numbers in this example, 61 and 53. In essence, in reality, it's going to be very large numbers. But to have a better example, 61 and 53. And then we're going to create the lambda, which is the LCM, the lowest common multiplier of P minus 1 and Q minus 1, which, if you want to do the math, is 780. And you're going to keep these secrets in memory. We're going to keep them secret, but you're going to use these to create both your public key and private key, which means that they're going to be mathematically linked. Now, your public key might contain a bunch of data, but it will also contain a modulus, which is the first prime number times the second prime number, and your public exponent, which is a coprime of lambda in this algorithm. And the private key is also going to contain that modulus, but instead of a public exponent, it's going to contain this private exponent, which is E with the modulus of lambda n. It's a bunch of fancy mathematics under the hood, but what you have to remember is that they're both linked, both the private key and the public key, because of those two prime numbers and the lambda that we created when we created those two keys. Now remember, modulus, public exponent, and private exponent, they're part of our keys. When we want to use a public key to encrypt some data, we're going to do something like this. Our input, 1, 2, 3, 4. It's a number just because that's easier. We're dealing with math underneath the hood. And our public key has a modulus of 32, 33, and a public exponent of 17. If you run it to the encryption algorithm of RSA, which is in the middle of this yellow box, you'll get a 2183 as an output. That's just some math. Usually you're not dealing with numbers, but you're dealing with text or other data, so you might have to do some data conversion. But at the core, it's always still this algorithm, this encryption algorithm using that public key, exponent, and modulus to do some mathematical equations. Now, if you want to reverse this, if you want to use our private key to decrypt that message we just created, we're going to do the same thing. So our output of our encryption thingy earlier was 2183. We're going to input it in our decryption, run it through the algorithm, and our original message shows up again, 1, 2, 3, 4. But instead of using our private or public key, we use our private key. And remember that these are mathematically linked to each other, both the public and the private key, which means that we can decrypt the message if we know the private key. Again, usually you don't use numbers, but you have something like a string or some other data. So there's some data conversion that is going on. But at the essence, at the core, it's still just that mathematical algorithm running in the background. Let's see why I cannot skip. Okay. So I created a little, very small script that you can link to in a second. But what this does is basically it's a node script, and it generates the two prime numbers, the modulus, the lambda, and the public and private exponent, and you can see it in action yourself. But like I said, we usually don't use small numbers, we use large prime numbers. So if we change the numbers, the first one and the second one, to something with more than 150 digits, we get very big numbers to work with. So we get very complicated mathematics. And if you like to see how I implemented this, note this is just for demo purposes. Don't use this in production. You can go to github.com/sambigo/RSA demo, and there's 3 ranges, one with simple numbers, one with large numbers, and one that does a bit of data conversion. But you'll see that the basics of RSA can be written in 63 lines of code, where the most mathematical thing is going on. We get a coprime, we get a random prime, and then we do some mathematical equations. So it's not that complicated. The basics, once you go beyond these basics, it gets quite complicated quite fast. But you don't need to know these because you should use a tested and proven library anyway when you're dealing with cryptography. Okay, we've seen all of the basics of cryptography: hashing, keyed hashing, signatures, and encryption. Let's move on to Jose, the thing that's actually in the title of this talk. And Jose, like I mentioned in the very beginning, stands for JSON Object Signing and Encryption. And this might not be familiar to you, but I think a lot of developers out there, especially if you deal with APIs and authentication once in a while, you might use Json Web Tokens. And Json Web Tokens are a part of the Jose JSON Object Signing and Encryption standard. So why JSON? The JSON format is often used for serializing and transmitting structured data over a network connection, which means that we use it all the time on the internet, right? Who uses XML these days? Everybody uses JSON. And it also has excellent support in most programming languages, especially in JavaScript. So it's very commonly used all over the place. So I mentioned JSON Web Tokens. Everything that's part of the JSON of the Jose standard is going to be JW something, JWT for tokens. But let's start with the more simpler examples. JSON Web Keys, because sometimes you want to share a public key. And remember, a public key is something you can share with the rest of the world. And you might want to share this over the internet. And we like to share things in JSON format over the internet. So we would like to create some JSON Web Keys, public keys in the form of JSON. And this is an example of a JSON Web Key containing my public key, or one of my public keys. But remember when we had a look at that RSA example where we created the public and private key, and the public key had the modulus and the public exponent, the N and the E value? Well, they're exactly, you can find these in this JSON Web Key as well, where the N is a modulus, it's the first prime times the second prime, and the E is the public exponent, which is the lambda, something mathematical with the lambda function. So both these values are in this JSON Web Key, together with some other information like which algorithm we're using and so forth. Next up, JSON Web Signature, where it's often, or most of the time, it's serialized as a string where you have the first part, dot second part, dot third part, and it's always going to be 3 parts a signature, a JSON Web Signature, where the first part is going to be base64 of a JSON object, which is called the header, the second part, the payload, and the last part is going to be the actual signature. So if we look at an example, and we would look at the first part, the Jose header, or the JSON Web Signature header, we base64 decode this. We get a JSON object, which tells us the algorithm that we've used to create the signature is HS256. So please use this algorithm to verify the signature if you want to verify it. The same thing for the payload. If we base64 decode this string, we get another JSON object. In this case, foo is bar. But as long as it's valid JSON, you can base64 encode it and put it as a payload of a JSON Web Signature. And lastly is a signature where we're basically going to check in the header which algorithm do you need to use. Now we're going to feed both the header and the payload into this algorithm together with the secret, because it's HMAC, which is basically a keyed hash and not a real signature. But if you would use another algorithm, you would input here the public key so you can verify the signature based on that public key. So you're just going to take the header, the payload, and your secret or public key, and you can verify the payload has not been tampered with. So like this, you know that everything that is in the payload was intended to be in the payload, and nobody tried to change something in that payload, because that payload is part of your signature. Key, signature, now it's up to Json Web Encryption. Again, we see the most common format of this is serialized as a string, but instead of 3 parts, it consists out of 5 parts. And this is where it gets a little bit more complicated. The first part is our header. We've seen this. If you base64 decode this, we get some JSON with some information about this JSON Web Encryption thingy. The second part is a JSON Web Encryption encrypted key. So this is the actual key we're going to use to decrypt our ciphertext, which is a 4-part, but it's still encrypted. So first we have to go and decrypt that one before we can actually use it. And the initialization vector, the 3rd part, and the authentication tag, the 5th part, are used to decrypt the cipher as well. But JWEs use 2 kinds of encryption. And like I've mentioned before, often when you're dealing with asymmetrical encryption, you're first going to or with symmetrical ones, sorry, you're first going to encrypt your actual key, the key you can use to encrypt and decrypt, with an asymmetrical one. So you can then decrypt that one with a private key. But that's what's being done with JSON Web Encryptions. So the content encryption key, the 2nd part, is usually encrypted with an asymmetrical algorithm. So if we take this 2nd part, it's going to be an encrypted secret key. So, and the 2nd part, the cipher, or 3rd part, 5th part, 4th part, the cipher is encrypted using that content encryption key, which is part of the string, but still encrypted. So what we're going to do is we're going to look into the header, and in the header tells us the algorithm, the encoding or encryption, and the key ID. So now we know which algorithms to work with. So if you want to decrypt the content encryption key, the 2nd part of this string, we're going to check in our header, which algorithm do you need to use? RSA, which we know from the example is an asymmetrical one. So we're going to take this algorithm, which takes the input, the content encryption key that is encrypted, but it also takes a private key because it's an asymmetrical one. And to decrypt something, we need a private key. So we know that we have the private key because the private key is something we keep secret, and it tells us the key ID. So it tells us which private key to use. So by looking into the header, we know which algorithm to use, and we know which private key to use. So when we know those details, we can actually decrypt the JSON Web Encryption encrypted key. And once we decrypt that key, we can use it to decrypt the actual encrypted message, the cipher. So again, we look into our header, which algorithm to use, A23 6GCM in this case. We pass along the cipher, the encrypted message, together with the decrypted content encryption key, together with the initialization vector, which is a 3rd part, which sometimes is empty depending on the algorithm, and together with the authentication tag, which is the 5th part. So first we decrypt the actual key, and then we use that key to decrypt the actual cipher, the encrypted message. It's a bit more complicated, but that's how JSON Web Encryption thingies work. And both JSON Web signatures, JWS and JSON Web Encryption, JWE, can be serialized as compact, as a string, as we've seen before, where JSON Web signatures are 3 parts and the encryptions are 5 parts, but they can also be serialized as JSON because it's a JSON standard, where this would be a signature. And again, you see you have your payload, you have your header, you have your signature. So all of the data is still in this JSON object, but structured according to the specification. And if we would look at a JSON Web Encryption thingy, this is how it looks like in the form of JSON. Now, why would you choose one form or the other? If you have to send it as a header, for example, in an API request, you might send it as a string because it's much shorter. But if you have all the luxury and all the time and all the size constraints that you want, you can just send the actual JSON object, and it's a bit easier to work with. But most of the time, we use these serialized as a string versions of JSON Web S, JSON Web signatures, and encryption. So I've touched on this. JSON Web Token is the last one in this HOSI standard that I want to be talking about. And a JSON Web Token is basically just a JSON Web signature or a JSON Web Encryption thingy, where most of the time is going to be a JWS. But if you really want to, you can also encrypt it so nobody can look inside of the payload without being able to decrypt the payload. But most of the time it's going to be a JWS. Where the only difference is going to be that in the header, you're also going to have type JSON Web Token, just so you know that it's going to be a token, that you have to treat it as a token. And some form of one of the most commonly used tokens these days on the web is an access token. So if you would look into the payload, you would see some information which is related to an API, to access an API, things like the issuer, the subject, which is usually a user ID, the audience and scopes, things like this. If it's an ID token, it's a token that's related to the identity of somebody that has authenticated. So it's going to contain a bunch of information about the identity of a user inside of the payload. But they're all JSON Web Signatures or encryption, which means they have a payload which you can either encrypt and decrypt, or you can sign so you know that nobody has tampered with the payload. So if we go to the summary, hashing compresses and makes it virtually impossible to get to the real data. It's a one-way function with a fixed size output. Keyed hashes protect the integrity of the data because we introduce a key, a secret key to these hashing algorithms. Digital signatures allow third parties to verify the validity and the origin of data. Encryption allows only authorized people to read the data, so only people who should be reading the data would be able to read the data. And the Jose is a set of standards based on JSON that helps us with signatures and encryption on the web, and most commonly to send them across the web in different ways. Again, if you would like to see these slides, they're going to be here on jose.sambigo.tech forever. They might evolve, but the essence is always going to be the same. If you want to know more about JSON Web Tokens, jwt.io. Our blog has a few very interesting articles, so auth0.com/blog. That being said, thank you very much.
Thanks so much, Sam. Yeah, there was a lot of content in there, so I'm glad you said that the slides are available to everybody. Yeah, thanks so much for the talk. That was awesome. Yeah, I guess we got a few questions in the chat, which is a good place to start. I've also got one or two of my own, and there's maybe just a little bit of a kind of base level understanding of encryption and algorithms that a lot of people don't have. We take a lot of these things for granted. You mentioned TLS.
Yeah.
So what actually is TLS then? So it has a way of it has some way of encrypting data, which is really useful for us, right? Stops man-in-the-middle attacks, right? Stops people seeing our data as it flies around the internet. But does it use just one preferred algorithm? Does it use multiple?
There's usually a whole range of algorithms you can use, and they all have their strengths and weaknesses. But I think if I go back to my slides, which is quite back, TLS, we had them with asymmetrical encryption, which means it still uses a public and a private key to do the encryption. So what's being used with TLS is something asymmetrical instead of a symmetrical algorithm. But in this range of asymmetrical encryption algorithms, there's a whole bunch of them, and depending on what you choose for what reason, they should all be okay to use.
Right. Awesome. Yeah, I'm definitely gonna pick over this. So I'm gonna call out a couple of questions people had. So one was about those very large numbers, those prime numbers you talked about. Yeah. So yeah, the question was from Sevtap. Do you want to ask it yourself?
Yes, thank you. You first of all, great. You deciphered this complex topic really well.
That was a goal. Thank you.
So you mentioned that we are using really, really large prime numbers. Then I wondered, how can one produce such a prime number? Because the search will be like, we will need immense amount of time to find such a prime number. How does one find it?
Well, there's also algorithms to do that. If you're a mathematician, that's something you might deal with on a regular basis. I am not. But if you look in this example that I showed, and maybe I can zoom in a little bit, we have this function get random prime, which is one of the algorithms that you could use to generate large random prime numbers. So this function will always spit out a large random prime number, and you can also say how big it needs to be. So it's, I think, 10-ish lines of code, but it will do that for you. There's more efficient algorithms out there, which are a bit more complicated, but what you need to remember is that there's mathematical algorithms that will generate these large prime numbers for you.
Thank you.
Does anyone else have a question for Sam?
Yeah, I guess I had a question. I'm not sure if it's really something that can be answered because I was reading articles about like quantum computers and kind of like how they can be used to break certain encryptions. Do you know anything about that, or is that an issue?
Yeah, so the reason why these algorithms that I just talked about are so secure are because they use these very big, large numbers. And if you want to brute force it, means that you have to calculate every prime number from 0 till you reach those kind of numbers, which is very intensive and practically impossible with our current computing power. Now, if you take quantum computers, they are so much faster than our current computers. So they would be able to theoretically crack these large numbers or brute force these in a very fast time. So I get this question a lot, and currently there's no solution to this because we don't really have quantum computers yet. It's something they're working on, but I'm sure once we have quantum computers, there's also going to be people who are going to create quantum encryption and decryption algorithms. So it's going to use the same thing, but then even numbers that are even bigger, I guess. Does that make sense?
Yeah, no, that makes sense. Yeah, cool. Cheers.
I think Dwane had a question as well, actually.
Yeah, about A to B and B to A in the browser. That's, like he mentioned, it's encoding and decoding. That's base 64 encoding and decoding, which is still something else. It does not create a fixed length output depending on input, for example. So it's not hashing. It's closer to hashing than any of the other things I talked about, but it's still something else. You're just going to encode it in a different way. So that's not secure at all, by the way. If you store something as base 64 encoded somewhere, it's usually just used to reduce the size of a string. Most of the time it's smaller, but that's about the only use case you have for it.
Yeah, good thing that you qualified that before anyone starts using that to store a password. Or
the output looks like a hash, but it is not a hash at all.
No. Great. Any other questions before we close up?
Any thoughts on the Web of Authentication API? Well, I have a whole talk about that if you really want to hear my thoughts. But the newest cool thing about Web Authentication API is also public and private key-based authentication on the web, which means you can use a YubiKey or a Titan key or a Google whatever key it's called, or you can use your Touch ID or something built into your device to generate a public and private key pair and then authenticate using that public and private key pair instead of using a password, for example. So I think it's a future. Adoption is getting along very slowly. It's getting better and better and better, but it's certainly something to keep an eye on.
Yeah, I'm glad that question was asked. I'm a fan of it because of the clear benefits to the user, right? I mean, there's so much convenience when a browser supports a feature like this. Browser
support is really good, by the way. All major browsers support it these days in some form or the other. And I think Google, GitHub, all of the bigger players also have some kind of support for it as a second factor or as first factor, depending on the service itself.
Yeah, it's a great way of managing credentials across different devices that you have, and so I've made a note, Sam, to ask you back at some point for your talk on that.
Glad you do that. Yeah.
Brilliant. Okay, I think we should wrap it up. But thank you so much to both of our speakers, Sam and Dwane, who've both, as I said earlier, beamed in from across the world, where we're going proper international these days, and why not, right? We're online. But yeah, Sam, Dwane, I would love you to come over to the UK sometime. Maybe you know, we can hope for that in the next 12 months. Who knows? But yeah, awesome to have you. Yeah, so a round of applause for our speakers. I can see lots of thanks appearing in the chat. I guess a round of applause doesn't work that well online, but yeah, I know everyone really appreciates all the effort you put in. Yeah, both really insightful talks. Thank you so much. And thanks everyone for joining. I'll see you in February.
Thanks. Bye-bye.
Thanks, Alex. Thanks, everyone. Take care.